Now the next topic, that is the Earth's magnetism. Now see, Earth itself behave as a magnet, and Earth have its own magnetic field. Okay. Now at the surface of the Earth, the magnetic field that is of the order of 10 raised to minus 5 Tesla. Now, why this magnetic field of Earth is there? Okay. So the reason behind this one, that is the magnetic field arises due to electrical current produced by the convection motion of the metallic fluid at the core of the Earth. Okay. And this particular effect, that is known as dynamo effect, and due to it the magnetic field of Earth presents. Clear to all of you? Now the magnetic field lines of the Earth resembles that of a magnetic dipole located at the center of the Earth. And this one is hypothetical one. Okay. The axis of the dipole does not coincide with the axis of the rotation of the Earth, but is presently tilted by approximately 11.3 degree with respect to the latter. In this way of looking at it, the magnetic poles are located where the magnetic lines due to dipole enter or leave the Earth. The location of the north magnetic pole is at latitude of 79.74 degree north and a longitude of 71.8 degree west, a place somewhere in North Canada. The magnetic south pole is at 79.74 degrees south and 108.22 degree east in Antarctica. Clear? Now the pole near the geographic north pole of the Earth, that is called the north magnetic pole. Likewise, the pole near the geographic south pole, that is called the south magnetic pole. There is some confusion in the nomenclature of poles. If one looks at the magnetic field lines of the Earth, one sees that unlike in the case of a bar magnet, the field lines go into the Earth at the north magnetic pole and come out from the south magnetic pole. The convention arose because the magnetic north was the direction to which the north pole of the magnetic needle pointed. The north pole of the magnet was so named as it was the north-seeking pole. Thus, in reality, the north magnetic pole behaves like the south pole of a bar magnet inside the Earth and vice versa. Clear? Now, to avoid this confusion given to you in this paragraph, simply we have to follow the regular sign conventions for any magnetic dipole or for any magnet or for any system which behave as a magnet. The field lines always comes out from north pole. So the point from where the magnetic field lines of Earth are coming out, simply say that is magnetic north. And the magnetic field line of the Earth enter to the point, so say that is the magnetic south. So in short, we can say the direction in which geographic north of Earth is there, there is the magnetic south. And in the direction of geographic south, there is the magnetic north. And you can justify this one also like this. When we place any magnet in the Earth's magnetic field, then north pole of that particular bar magnet always align towards the geographic north, and magnetic south pole of that bar magnet always align towards geographic south pole. Now we know this thing. The unlike poles attract each other. So if we imagine the Earth as a magnet, so suppose this one is the magnetic moment of Earth, or we can say we consider Earth as a magnet. Now above it, if bar magnet is there and this one is the north pole of the bar magnet, it implies that this should be what? The south pole of the Earth, because north south attract each other. And if the south of the means magnetic south pole of the bar magnet is aligned in the geographic south direction, it implies that this particular the one that is north pole of the Earth, because north attract south and south attract north. So without confusion, simply you can represent this thing in this way. Clear to all of you now? This particular second figure, that is just for understanding, to avoid this particular confusion, or in other words, we can say to make clear our mind. In exam, you have to write only up to this one as per given to you in the text. Clear?